Hello, this is Provani, Assistant Professor in IT Department at SMIT. We are going to see about the artificial intelligence and machine learning. Okay, course outcome. Course 1 will be studying about the uninformed and heuristic search techniques. Course 2 learn about the techniques for reasoning under uncertainty. And then 3 introduce about machine learning and supervised learning algorithm. Course 4 studies about the ensembling and supervised learning algorithm. Learn about the basic of deep learning using neural network will be course 5. Now we are moving on to unit 2, probabilistic reasoning. Actually, introduction to probabilistic reasoning. It is a core concept in artificial intelligence and machine learning that deals with decision making under uncertainty. Unlike deterministic system, intelligent agents often operate with incomplete or noisy information. Probability theory provides a mathematical frameworks to model uncertainty and reason logically. It allows AI system to predict outcomes, evaluate risk, and update belief. This approach forms the foundation of many modern AI models. Understanding probabilistic reasoning is essential for intelligent behavior. It allows AI system to predict outcomes, evaluate risk, and update belief. Probabilistic reasoning is widely used in diagnosis, prediction, and decision support system. Actually, it is the method of reasoning that deals with uncertainty. Instead of assuming that the facts are always true or false, it represents knowledge using probabilities, allowing us to make a rational decision even when information is incomplete, noisy, and uncertain. Actually, let us see why probabilistic reasoning is needed. In real world situation, data may be incomplete or ambiguous. Observation may be noisy or unreliable. Outcomes may not be deterministic. For example, medical diagnosis based on symptoms, weather forecasting, spam email detection, fault diagnosis in networks. The basic concept in probability will measure the likelihood of an event occurring. It ranges from 0 to 1, where 0 means impossible, 1 means certain. Okay. See, let P of E equal to number of favorable outcomes divided by total number of outcomes. Then see about the random variables. It represents an uncertain quantity. Two random variables will be there, discrete and then continuous. Discrete takes finite values and then continuous takes infinite values. Example, temperature. For discrete we can say dice outcome. Event is nothing but set of possible outcomes. Getting a even number when rolling a dice. Okay. Moving on to acting under uncertainty. It refers to make decision when outcomes are not fully predictable. AI agent often lacks complete knowledge of the environment. Uncertainty may arise from sensor noise, incomplete data, or dynamic changes. Probabilistics models help agents choose acting with the highest expected utility. Decision theory combines probability and utility to guide actions. Rational agents evaluate possible outcomes and their likelihood. This approach improves robustness in real world application. Example includes robotics, medical diagnosis, and finance. Okay, now probability based in AI. Probability theory is the backbone of probabilistic reasoning in AI. It defines how likely an event is to occur. Key concepts include random variables, events, and probability distribution. Conditional probability represents the likelihood of an event given another current. Joint probability captures the relationship between multiple variables. These concepts allows modeling of complex systems. They help quantify uncertainty in a precise manner. AI systems rely on these principles for reasoning and learning. Actually, see in AI, probability provides a mathematical framework to represent and reason for uncertainty. Since AI systems often operate with incomplete, noisy, and ambiguous data, probability theory is essential for making the rational decision and prediction. Actually, see why probability is important in AI. It must be often predict outcome, example weather, stock prices, classify data which is spam versus non-spam, make decisions under uncertainty which is robot navigation, learn from incomplete data, example medical diagnosis. Actually, probability allows AI to quantify uncertainty and choose the most likely or optimal actions. Core probability concept used in AI will be sample space, event, probability of an event. Okay. Sample space is the set of all possible outcomes of an environment. Example, rolling a dice. Event is a subset of the sample space, rolling an even number, which is 2, 4, 6 like even numbers. And then probability of event measures how likely an event is to occur. Number of favorable outcomes divided by total outcomes. Okay. And then random variable is also topic under probability basic in AI. It's map outcome to numerical values. Type will be discrete random variable and then continuous random variable. Discrete random variable will be finite values. Continuous random variable will be infinite values. Moving on to probability distribution, describe how probability are assigned to random variables. Okay, common distributions in AI method will be Bernoulli distribution. It's binary outcomes, yes or no. And then binomial distribution, number of success. And then Gaussian normal distribution, real world data modeling, multinomial distribution, multi-class problems. There will be probability with joint, marginal and conditional probability. Joint probability, the probability of two events occurring together, which is A comma B. Marginal probability, probability of single event ignoring others, which is P of A. And then moving on to conditional probability, discussing about probability of A given that the B has been occurred. P of A by B equal to P of A comma B by divided by P of B. This is fundamental in AI reasoning and then learning. In this we'll be discussing about the Bayes theorem also, which is the foundations of AI reasoning. It's nothing but is to update belief based on new evidence. P of H by E equal to P of E by H into P of H divided by P of A, where H represent hypothesis and E represent evidence. Okay. And then moving on to independence in this probability. Two events of A and B are independent if A comma B is equal to P of A into P of B. This assumption simplifies many AI models. Moving on to Bayes theorem. Provides a formal rule for updating probability. It relates prior, likelihood and posterior probabilities. The theorem states how evidence influences belief. It expressed as saying P of H by E equal to P of E by H of P of H into P of E. This is the formula in fundamental to Bayesian reasoning. It helped reverse conditional probability. Bayes' theorem is applied in diagnosis and forecasting. It forms the basic of many AI algorithms. Let us say why Bayesian theorem is important in AI. Why? Because Bayes' theorem it handles uncertainty effectively. It allows learning from new data, suppose rational decision making, forms the basic of Bayesian inference. Actually, the Bayes theorem in AI, key application will be Naive-Bayes classifier, spam filtering, speech recognition, image classification, expect system, medical decision supports. Special cases in Bayes with multiple hypotheses will be P of H base I divided by E equal to P of E by H of I into P of H of base I divided by whole thing sigma of j P of E by H of j into P of E H of j. Okay, this is several competing hypotheses exist. Moving on to Bayesian inference. It is method of updating belief using evidence. It is based on Bayes' theorem. Prior probability represents initial belief before observing data. Likelihood measures how well the data supports hypothesis. Posterior probability is the updated belief after considering evidence. Bayesian inference allows continuous learning from new data. It is widely used in prediction and classification tasks. this method initiative and mathematically sound. Thank you.